So now we're going to use one of our tangent formulas. And it's the sum formula because it's addition. So tangent alpha plus beta is equal to, let's see if I can remember it, tangent alpha plus tangent beta. I don't want my t and my plus sign to look the same, but anyway, over 1 minus, because it's going to be the opposite sign, tangent alpha tangent beta. Okay, so we have an alpha, we have a beta. Alpha is going to be pi over 6, and beta is going to be pi over 4. So we're going to have tangent of pi over 6 plus tangent pi over 4 all over 1 minus tangent pi over 6 tangent pi over 4. I guess the good news is you get to kind of reuse them, so we only have to know 2 values here. And again, we're going for exact value. Okay, so what's the tangent of pi over 6? Let's see, pi over 6, 30 degrees. I'm thinking it's the square root of 3 over 3. Okay, what's the tangent of pi over 4? I'm thinking that's 1. I don't really want to write a 1. It's 1. I want to write 3 over 3. Get my common denominator right off the bat. Okay, so I think I'll do the same thing down there. Well, maybe not. Well, let's put the 1. Okay, minus, because we don't really know what's going to happen here. So we're going to have the square root of 3 over 3 for the tangent of pi over 6. That's that part. And then the tangent of pi over 4 was just 1, wasn't it? Okay, so I guess I was okay. Well, now we have to simplify it. So I've got 3 plus the square root of 3 over 3. That's the numerator. Then in the denominator, I have 3 minus the square root of 3 over 3. So you can invert and multiply, or you can just cancel these denominators. That's okay to do. They're both in the denominator. But if that's like confusing to you, just invert and multiply. It'd look like this. And then you can cancel them that way. Okay, and so my final answer is going to be 3 plus the square root of 3 over 3 minus the square root of 3. Okay, so I didn't put a box around my answer. I'm going to put a box around my answer. It's a lovely answer. Okay, it is not the answer that the textbook has. They took a different approach. So I want to explain this a little bit because your answer is going to look different if you go this other route, and the values are the same, okay? And sometimes it's tricky to see that it's the same thing, okay? If you remember, we had tangent, well, okay, yeah, I'll go ahead that way. Tangent pi over 6 plus tangent pi over 4 and 1 minus tangent pi over 6 tangent pi over 4. Okay, that's what we started with. Well, when I put this in, I used the expression that has a rationalized denominator. They didn't. They put 1 over the square root of 3, which of course annoyed me because we usually write the tangent of pi over 6 as the square root of 3 over 3. So we rationalized the denominator, but they didn't. Okay, plus, and then this was still 1. And then here, same thing. Okay, so when we do that, in the numerator, we're getting 1 plus the square root of 3 over the square root of 3, okay? And then in the denominator, you're going to get the square root of 3 minus 1 over the square root of 3, and then those are going to cancel. And then just the one little modification they made is they wrote square root of 3 plus 1 over square root of 3 minus 1. Now, it does look different than my answer. My answer looked like this. Their answer looks like this. It's okay. They're equivalent. Okay, they're the same value. Now, if you're like, well, how would I get, my answer to look like theirs? You could unrationalize the denominator, which would be a big hassle. You could multiply by, though, 1 over the square root of 3 in both the numerator and the denominator, and then it would all work out so it would look like this. But I don't think it's necessary to do that. I would use the rationalized denominators and get that answer. They didn't. They got this answer and they didn't use the rationalized denominators. See, they have 1 over the square root of 3. Okay? So I don't really care which way you do it. Either way is fine with me. I would do it this way. So that's just what I'm saying. Okay, you don't have to do it my way.